Hi everyone, Mr. Smith here with an introduction to prime factorization video. Our learning objective, students will find the prime factorization or prime factors of composite numbers. Our essential question, what is prime factorization? Prime factorization is simply finding all of the prime numbers that make up a composite number. Check out these examples. So 20 is equal to 2 squared times 5. 2 squared means 2 times itself, or 2 times 2, and that's 4, and 4 times 5 is 20. And 24, 2 to the third power times 3. 2 to the third power does not mean 2 times 3. It means 2 times itself 3 times. 2 times 2 is 4, times 2 again is 8. 8 times 3 is 24. 30 is 2 times 3, that makes 6, times 5 is 30. 36, 2 squared times 3 squared. 2 squared means 2 times itself, that's 4. 3 squared means 3 times itself, that's 9. 4 times 9 is 36. And 39, 3 times 13. This video will show you how to find the prime factorization of a composite number using a tool called a factor tree. So I will show you, these were the answers. On the next slide I'm going to show you how to get them. One easy way to make a list of all the prime factors is to use a factor tree. On the right here we have some text that tells us how to use a factor tree. We're going to read that, highlight the important stuff, and then I'll show you how. How to use a factor tree. Choose any factor pair to begin the tree. If a number in this pair is prime, circle it. So we're going to circle the primes. If a number in this pair is composite, draw additional branches and write the factors. Continue adding branches until the factors at the ends of the branches are prime numbers. Remember, if they're primes, we circle them. Lastly, write the prime factors from least to greatest using exponential form when possible. Now that's a lot of directions and you might not be able to memorize all of them, so we'll leave this posted. Let me show you how it works. We're going to use the same problems we used on the previous page. So we're going to do these numbers right here. We're going to start with 20. And 20 is a composite number. It has factors other than 1 and 20, so I need to draw branches. I know that because it says right here, if a number is composite, draw branches. Okay? So what do I put at the end of the branches on 20? Well, it's just any two numbers that make it true. For example, I could write 2 times 10. 2 times 10, I'm not going to put the x there for multiplication. You just need to memorize the fact that these are all multiplication problems. I'm not going to keep doing the x there because we just don't need to. But is that true? 2 times 10 is 20? It is. Now, some kids would say, well, what if I want to do 4 times 5? Well, I'll do parallel right here. I'll do 4 times 5. Are both of those statements true? They are. We will end up with the same set of prime factors at the end, so I'm going to do the one on the left first, and I'll come back and do the one on the right and prove it to you. Anyway, go back to our directions. If a number in this pair is prime, circle it. 2 is prime. If a number in this pair is composite, draw branches. 10 is composite. So my new question is, how do I make up 10? Well, it's simply 2 times 5. 2 is prime, and 5 is prime. I'm pretty much done with that problem. I want to prove to you that if a peer, or if another student did 4 times 5 first, they'll still get the same numbers. 4 is composite, so it needs branches. 5 is prime, so we circle it. 4 is made up of 2 times 2, and both of those 2's are prime. I want you to notice the tree on the left. I have a 2, and a 5. 2 times 2 times 5. And I want you to notice the tree on the right. I have a 2, and a 5. 2 times 2 times 5. So what I just proved to you, and I'm not going to do it again, what I just proved to you is that if I give you 20, and one kid starts with 2 times 10, and a different kid starts with 4 times 5, you still get the same answers. Okay, so at the end it says, write the prime factors from least to greatest, which we did, using exponential form when possible. What that means is right here, 2 times 2 can be written as 2 squared. 2 is the base, and the square indicates that there are 2 2's. And then we go times 5. And it would be the same over here because it's the same numbers. 2 squared times 5. We already knew that because look, it's pointed right there. 2 squared times 5. Let's try 24. 24 is a composite number, so it needs branches. 24 can be made up of 2 times 12. 2 is prime. 12 needs branches. 12 can be made up of 2 times 6. And 6 is 2 times 3, both of which are prime. Count the 2's. There are 1, 2, 3 2's. 2 is the base, and it gets multiplied by itself 3 times. So that's 2 to the third power, and there's a 3. 2 to the third power times 3, which, like I said, we already know because we have the answers right here. This page is just showing you how to get the answers. Let's check out 30. 30 is composite, so it needs branches. I would do 30 as 5 times 6. 5 is prime. 6 is not. 6 is 2 times 3. Both of those are prime. My factors are 2 and 3 and 5. And there are no repeats, which means I'm not going to use any exponential form. Let's try 36. There's 3 different ways you could start 36. You could do 4 times 9, or well, you could do it 4 ways. You could do 2 times 18, 3 times 9, 3 times 12, 4 times 9, or 6 times 6. It doesn't matter. I'll just choose 4 times 9. It doesn't matter as long as it's true. 4 and 9 both are composite, so they both get branches. 4 would be 2 times 2, and those are prime. And 9 would be 3 times 3, and those are prime. And there are 2 2's, so that's 2 squared. And there are 2 3's, so that's 3 squared. And you put a little dot there for times. And we already knew that. It's right there. And let's just do one more. 39. 39 would be 3 times 13. 3 is prime, and 13 is prime. Sometimes prime factorization is as simple as finding 2 prime numbers that make up a composite number. 3 times 13. All you would write is 3 times 13. Alright, let's move on and try some larger numbers. I encourage you not to be intimidated by the larger numbers. They are often just as easy. They just require more branches. We're going to use our same set of directions here. And if you'd like to do the pause here video and then check your answers, you can do that. Or if you want more instruction, that's fine too. So I'm going to start with 250. And we have to remember some divisibility rules here. For example, numbers that end in 0 are divisible by 10. And so how would I make up, what would 10's partner be? Well, what times 10 makes 250? It's just 25. And that makes sense because if you multiply 25 by 1, you get 25, and then you annex a 0 to the end of it. 25 times 10 is 250. 10 and 25 are both composite numbers, so they need branches. And 10 is made up of 2 times 5. 25 would be made up of 5 times 5. Now, I don't think anyone's confused about this part right here, but I do want to take a minute to point out what mistakes some kids make. So I'm going to go back in time for a minute. And what I've seen before is below 10s, I've seen things like 5 and 5. Because what kids are thinking there is that we add 5 plus 5 makes 10. And that's true, 5 plus 5 does make 10. But I pointed out to you at the beginning of the lesson that these are all multiplication. And so we put numbers here that multiply to make 10. So don't make that common mistake. It's 2 times 5 makes 10, and 5 times 5 makes 25. Those are all prime numbers. Remember, we write them from least to greatest. 2 times 5. How many 5s are there? 1, 2, 3. 5 times 5 times 5 can be written as 5 to the third power. 2 times 5 to the third power. Let's check out 490. 490 is another one that ends in 0. So you could do the same strategy there where you're going to multiply 10 by something to get 490. It's going to be 10 times 49. But you also might have noticed that it was divisible by 7. 7 goes into 49 7 times. And 7 is prime. And 10 needs branches. 10 makes 2 times 5. So if we do them in order from least to greatest, we have 2 times 5 times 7, but there's 2 7s, so we square it. 2 times 5 times 7 squared. All right, let's try 1,000. Again, don't be intimidated. Just because it's 4 digits long doesn't make it difficult. There's different ways to do 1,000. You could do 10 times 100. You could do 2 times 500. I'll do 10 times 100. And 10 we've done a couple times. That's just 2 times 5, and both of those are prime. And 100 would be 10 times 10. And I just did a 10, which is 2 times 5. And another one is another 2 times 5. Right up here. They are often just as easy, they just require more branches. Anyway, you have to count. The hardest part might be, or at least the trickiest part might be, counting all of the prime factors that you circled. And this is where it's important to remind you to always circle your prime numbers. If you leave a prime number uncircled, you might not notice it in your answer. So I've got 2 times 5, 2 times 5, 2 times 5. So I've got 2 and 5 are my bases, and then you count them. How many 2's are there? 2 times 2 times 2, that's the same thing as 2 to the third power. How many 5's are there? 5 times 5 times 5. It's the same as 5 to the third power. It's simply 2 to the third power times 5 to the third power. Let's do one more. Let's do 11,000. And there's something kind of interesting about 11,000 compared to 1,000. You'll see it in a minute. So 11,000. Oops, I wrote 11,100, and it's not. It's 11,000. So some kids might not know where to start here. I'd probably start with 11. 11 goes into 11,000. 11 times 1,000 would be 11,000. And 11's prime. Now right now you might already notice, hey, isn't this going to be the same branches that we just did? And it is, because just a minute ago we did 1,000. Do you see this 1,000 right here? Just a minute ago we did 1,000. And so if on the very next problem we have 11,000, it's actually going to be the same problem, kind of, just with an additional prime number of 11. If you're confused about what I'm saying, you probably see it at the end. So I'm just going to repeat the same steps I did. 1,000 would be 10 times 100, and 10 is 2 times 5, and both of those are prime. And 100 is 10 times 10. Neither of those are prime, so they need branches. And this 10 is 2 times 5. And this 10 is 2 times 5. And my 2's are, there's 1, 2, 3 2's, so that's 2 to the third power. And my next largest is 5, 5, 5, 5, that's 5 to the third power. And my last one is that 11 up there. So if I write it under this answer, notice it's 2 to the third power times 5 to the third power times 11. And you might say, hey, it's practically the same answer, just with an 11 at the end. And that should make a lot of sense, because this prime factorization right here is 1,000, and so this one would be 1,000. And then if you multiply that by 11, it would be 11,000. Great job! You are now ready to complete the prime factorization lesson in your book. Thank you for watching.